And now this is our last function, the absolute value function. So remember, the absolute value function means whatever x value plug in, whether it is positive or negative, the y value that comes out is positive. So this is the function that has the v for absolute value, unlike the quadratic, which does not have a v shape. This one does. Now, I want you to take a moment before you go to the graphing software. What do you think the half in front of the x does? For the second question, I've rearranged it. Think about for a moment why I've rearranged it and what each of those things does. So what does the negative sign do in front? What does the +1 do? And what does the +2 do? I'd like you to take a moment, think about it, and then once you've thought about it, use the graphing software to decide what happens. All right, so if you took a moment to think, remember this is the b value. So this is a horizontal stretch by a factor of 1 divided by whatever that number is. So 1 divided by a half is 2. So this is a horizontal stretch by a factor of 2. So if I use my graphing software here, again, my original is in the red. My transform function is in the blue. Look at my key point, P, which was 4, 4. Look at Q, which is now 8, 4. So what's happened is that all the x values have been multiplied by 2. The domain here is still x is an element of real numbers. The range is y is everything greater than or equal to 0. And here the vertex kind of means the apex of the function. So in this case, it's still 0, 0. All right. So for this example, I would like you to tell me, what does the negative do? What does the +1 do? And what does the +2 do? Think about it first, then use the graphing software to confirm. Okay, so if you've thought about this for a second, you know that the negative sign reflects it in the x-axis. It goes 1 to the left, and it goes 2 up. So if I draw my handy diagram, it goes 1 to the left and 2 up. Here is my new vertex. My new vertex is at -1, 2. It opens down now, and there is no stretch factor. So it looks like this. Let's confirm with my software over here that I've done the same thing. Boom. There's my key point from 4, 4 to 3, -2. And my domain is still x is an element of real numbers. My range now is y is everything less than or equal to 2, and y is an element of real numbers. So let's say I wanted to do this using point notation. How would I do this using point notation? Well, x comma y means, so do you remember what it will look like? Well, the negative, what does it apply to? The x or the y? Well, in this case, it applies to the y. It went, oh, there's my little handy notification to go to bed. And then it says +2, and this is x minus 1. So, in my lovely diagram, it gave me the point 4, 4. So let's give that a try. So if I have my point 4, 4, and I want to see where it goes, so 4 minus 3 is 2, and -4 plus 2 is -2. Well, let's look at my handy dandy diagram. Did it show up at 3, -2? Yes, it did. So my point notation always works. Okay, take a moment. Let's summarize. What have you seen now? Well, hopefully, regardless of any transformation or any function, so any function will follow the patterns for transformations. Regardless of what that function looks like. So it could be a parent function that we've just spent all this time discussing, or it could be a zigzag function that we spent some time doing last time. It doesn't matter. Any function all functions will follow the patterns for transformations. Now remember, if I have a generic function, the a value is a vertical stretch by a factor of a. The b value is a horizontal stretch by a factor of 1 over b. Don't forget that. C is a horizontal translation, otherwise known as left or right. D is a vertical translation, otherwise known as up or down. If I change that into point notation, from point notation I can say this is x comma y. Any point becomes a y plus d and 1 over bx plus c. Again, the generic form, this is general. You have to look at what function they give you. So either A, a parent function, or B, a zigzag function. And then can you move those respective key points that we've been talking about? All right, people, it's time to do some practice. Make sure you get at it. As a friend once said to me, pitter patter, let's get at her.